Hello, my name is Daryl, and this is Programming in Any Language. We are working with C# right now, but the principles are the same in all languages. Master these principles, and you can easily jump to any other language quickly. You'll notice behind me there are several bubbles or circles, if you will. There's a square up there as well. The square represents why we program in the first place. It's to solve problems of some kind. And when we solve a problem, we may or may not involve the computer. But that decision, however, is better left for a class in systems analysis. For us, we are learning to program, and so our problems will very definitely involve the computer. That's our whole point. That leads us to why all those bubbles are up there. Those are the tools found in all programming languages that we use in solving our problems. And each of those bubbles represents many different tools, all of which are categorized by the name found in the bubble. You can see data storage, arrays, methods, loops, object-oriented programming, or OP. We'll get to all of these later, but now we'll concentrate on decision structures. Up to now, we have spent the bulk of our time understanding variables. We've learned to do math of them. We've learned to convert them to different data types. We've learned to concatenate string variables. We've learned how to use them with controls. And we've learned some controls too, labels, buttons, text boxes, and so on. And those controls have allowed us to set up forms using a graphical user interface, the GUI. Controls, variables, and the GUI are things we've covered up to now, which pretty much forms the groundwork or the foundation for everything that comes next. Up to now, we have been doing straight line programming, one line of code following another, and then it's done. That pretty much limits what we can do. So it only makes sense that we expand on that. We'll continue to use variables, controls, and the GUI. And we'll add to our knowledge in this area as we continue on our journey. But now we get a chance to expand what our programs can do. Each of the other bubbles on this chart are specific topics that will allow our programs to do things not possible with what we've learned so far. And programming languages make use of those other topics as well. The first of those is the decision structure. The tools in the decision structure allow our programs to branch off in other directions. For example, if we wrote a program to calculate gross pay, it would be a simple matter of multiplying the hours worked times the pay rate. That limits us. What if the person worked overtime? And the overtime hours were paid at a different rate, say time and a half. That's pretty common. Our program would need to determine if overpay is warranted. It can only do that by determining if the hours the person worked exceeded the normal hours worked. To do that, we would use an if statement. And in programming, 30 years ago, that pretty much defined the decision structure. There wasn't anything else, just an if statement. Today, that has greatly expanded. Behind me, you can see a list of the topic I've thrown together which belong to the decision structure world today. There's the if statement that we just talked about. It's followed by an if-else statement. Instead of branching out, this structure allows you to go in one of two directions. We'll examine that in detail as it is used a lot. Nested structures. What the heck is that? Basically, you can have a decision within a decision. For example, if female and if age greater than 30, do something. First you're checking the sex, then you're checking the age before you take any action. Logical operators are a component of the if statement. If greater than, if less than, if equal to, and so on. They will become part of your decision structure. Boolean or bool are simply flags. If true, do this. If false, do this. We'll see how useful these flags are as we work through these topics. Comparing strings. Ever wonder how passwords are checked? How login IDs are verified? Welcome to the world of comparing strings. Try parse. We've seen the try-catch method. We've done that in the past. Does a nice job of preventing blowups by catching virtually any error, but it's not specific. The try-parse method is a decision made on a specific line of code. Is that quantity valid? Is that price valid? Try-parse gives us the ability to tell the user exactly what's wrong with their entry. Input validation. Besides try-parse, we may want to check the user's input based on reasonability. If you're selling items in a local mom-and-pop grocery store, is it reasonable for a person to come in and order 1 million pizzas? Or negative 100 pizzas? Probably not. Input validation will allow us to only allow data into our program that makes sense. How about those radio buttons and text boxes? Those are controls. But they are controls which help our program make decisions. Person ordered a pizza and they want green peppers, pepperoni, sausage on it. Each checkbox can be interrogated to see what ingredients the user has requested. Finally, the switch statement. This wonderful feature is similar to the if-else, except it uses far less lines of code and is structured to make it more readable. I'll show you a Magic 8-Ball program which will demonstrate this tool nicely. That's a lot of stuff. And you might have gathered that this just might get a bit confusing. Well, yes, it can. Depending upon how complex your program gets, how many ifs and elses you need, the programming logic can get quite confusing. Enter flowcharting. There are programs you can use to flowchart your code, and I'll be using some of them in the upcoming videos. Back in the day, however, this was done with pencil and paper using a template like the one you see behind me. And the manual method of flowcharting is still a great way to develop your code. It can be relaxing as you lay out how your program is going to work. And when you have a design, the flowchart becomes the plan, the architectural blueprint for entering your code. There's an old saying out there. Read it in a programming book many years ago, and it's still valid today. 80% of programmers need to flowchart. 20% can visualize the program in their head and don't need to flowchart. The problem is that 80% of the programs think they belong to the 20% group. I'm not that smart. I need to flowchart. You'll see that in upcoming videos. Get ready for a good ride. We're going to master all of these tools available for decision logic. What do you need to take out of this video? Basically, decision structure is but one major programming topic. There's a whole lot of subtopics in decision structure. Flowcharting will help us plan complex programs. See you next time. Thanks for watching. If you get a chance, please subscribe, and we'll see you in the next video. Take care.